All right, 3.2. We're going over this. We've done this. We've just done it in the reverse. Okay? These are what discontinuous functions look like. Discontinuous functions are functions that are kind of put together and they're separate functions, right? So you've seen those on your first test. You know, the ones that were like this. The ones that look like this, and then maybe they look like that, and then they go back down like that, or something like that, right? Or discontinuous, meaning maybe this actually starts
Anthony's so messed up for your post.
Here.
He said skating.
And this is an open circle, and this is a closed dot, right? Or maybe it moves off to a side or something like that.
Switch. Max got you. He said win.
Guys, I'm recording. So, with 41, 42, 43, what I'm looking for is, with 41, we're just going to graph these. Okay? So, I'm graphing this 2x plus 3. Okay? Because I'm just showing this really quick. And then I'm moving over to 3.3. Like I said in the beginning, this is only to give you an understanding, because we've already seen this. We worked it backwards, right? You had to come up with this. Well, you actually just came up with this, right? But it's not that hard to do this. So you got 2x plus 3 and x squared, right? And that's your function, okay? And it's called the discontinuous function. Well, it's not a discontinuous function, it's a multiple function, right? It's discontinuous if we got to lift the pencil. In this case, I don't think we do, because they're saying for this one, they're saying if x is less than -1, right? So when x is less than -1, so if I were to graph this, guys, what do I do next? Do you know? Then that's why we listen. Okay? If I'm going to graph 2x plus 3, it's really easy. 1, 2, 3. 2x plus 3, I start here and then I graph. Up 2, over 1. Or down 2, left 1, right? And I've got this graph. Now, it says when x is less than -1, right? So what happens there is, where's -1? Right here, right? So all this graph goes away. Yep. The only thing that's there is this point, right? And then this line.
Isn't it an open dot? Or am I just confused?
It's what?
Is it open dot? That's not
Ah, yes. So because it says greater than, right? Or less than in this case, this is going to be an open dot at -1. Right? And then the next one says greater than or equal to, right? So for this one it's saying, let's do that in red. If x is greater than or equal to -1. Okay? So this is not a discontinuous, right? This is a continuous function because it continues. It goes along all of the x's, right? Now, if this said greater than 0, right? That would be discontinuous. It would start a little bit over. Okay? But I'm just looking at x squared. Now, if I look at x squared, graph x squared, and I know that that's 0. I know that this is 1 and 1. And I know that at 2, I'm going to go up to 4, right? And then at 2, I'm going to go up to 4. Right? And it just looks like this. Okay? Now, for this function, it's saying for x is greater than or equal to 1, all of this goes away. going up to this point. But that's graphing a multiple function. Okay? And so we got to be able to do that. That function that we did at the beginning in chapter 1, that's all we're doing here. Except this time, I'm going to have you figure out what the functions are. Okay? So, again, for 42, we would graph this linear function. We would graph this linear function because they're both linear, correct? And then we would just accept the part that isn't. So this is linear because it has an exponent of 1. This is linear because it has an exponent of 1. Graph both of them. Erase everything less than -1. Erase everything greater than negative or at 1, and erase everything less than 1. So to show that really quick, okay, if I'm doing the absolute value of x, right, and what was the other one? -3x plus 4, okay. All right, let's do one of them in red. Might as well do. We've got a graph, right? 1, 2, 3, 4. Down 3, left 1. And so I have this graph right here. Okay? And then I look at it and go, okay, that one is if x is greater than or equal to 1. So I look at 1, and where 1 would be up 3. Wait a minute. Down 3, right. This should be negative. Sorry about that. This should be down 3, right 1. There we go. Okay. So this should be coming down. Oh, that's really ugly. There we go. A little better. Okay, and it's coming at this point right here and equal to, and everything other than this point is gone. Then I graph this guy, say in red. And this is going to be x is less than 1. And the absolute value of x, well, what is, if x is 1, then y is 1, right? Okay? If x is 0, y is 0. If x is -1, y is 1, because it's absolute value, right? And it's just going to go up like that. It's going to go up like that, right? But in this case, it doesn't care about all of this. And this is an open circle, right? And all it cares about is this side. Is where x is less than 1. Does that make sense? Okay? And so that will be on your test.